All right, which diagram best represents the relationship among integers, rational numbers, and whole numbers? Okay, remember that they are all rational numbers. And then we have integers, and then we have whole numbers. That would be D. Remember that it is a progression, okay? These are, this is saying that all of them are whole numbers, not true. This is saying that all of them are rational numbers, but that integers and whole numbers are two completely separate things. That's not true. Integers include positive whole numbers. And then this one is saying there's whole numbers, but there's also rational numbers, and some of the rational numbers are integers. That's also out of order. So your correct answer choice should be D. Number 14. Mr. Jemison earns $24 per hour working. He qualifies for a 15% raise in his salary. What is his salary after his raise? Okay, well, we need to know what 15% of 24 would be. Okay, so 15% over 100 is equal to something over 24. Okay, so I can make this 3, and I can make this because I divided by 5. I'll show you my thinking. And I divided by 5 here. And then this would be a 20, and that makes my it makes my numbers a little bit smaller to work with. Okay, so then I have 320 is equal to x over 24. There's not, oh, gotta move my paper up. Sorry. There's not really an easy relationship that I see between 20 and 24 or 20 and 3 or any of those things. So what I'm going to do is say 20x is equal to 72. Okay, I multiply this way, and I'm going to divide both sides by 20. X is equal to 3, and then 12 over 20, which simplifies to, both of those are divisible by 4, 3/5, so $3.60. So what is his salary after his raise? Well, we started with $24. We added $3.60, and that would be $27.60 per hour, which is F. Okay, one more thing. If I didn't want to do all this, because that was a lot of work, okay, I could think about something that I know, okay? If we're talking about $24, 10% of $24 would be $2.40, okay? I would need that other 5%. Well, if 10 divided by 2 is 5, then $2.40 divided by 2 would be $1.20. And if I combine both of those amounts, that would be $3.60. And I could combine that with my 24. So his raise would be $27.60. Okay? So you could think about it either way. This one is just a little bit more flexibly thinking. If you know your benchmark fraction of 10% and moving the decimal, if you weren't sure how to do that, you would need all the extra steps here. Okay? All right, 15. What constant rate of change is shown in the graph below? So you know rate of change, our change in y over our change in x. Here's our x-axis, here's our y-axis. This one's proportional, so it's starting at 0, okay? So we can use 0 as a starting point. Then it is always recommended to go to a place that is very easy for you to see in your graph. And by easy to see, I mean right at the intersection of 2 points, okay? So we have an intersection here at 2, 5. So basically, we're going from 0, 0 to 2, 5. I'm looking for my change in y, so I'm going to look at my y-axis. I'm going from 0 to 5, so my change in y, some people call this my rise, is 5. Okay, it's a positive 5. My change in my x, because that's going the same direction as my x-axis down here, is going from 0 to 2. So I have 5 divided by 2, and that's going to give me 2.5, 2.5. Okay, 2 5/10. So my rate of change for this representation would be 2.5. All right, guys, so it's going to be recommended to you that before your CBA, if you are struggling with any of these, that you take advantage of your particular teacher's tutorials and let us know if you have any questions. As always, if you were in Mrs. Brown's class and you have discovered that Mrs. Brown made a mathematical mistake, because, hey, it's quite possible, go ahead and very politely email me to tell me what mistake that you found, and you know what happens after that. Y'all have a good day. Bye.